We're now going to begin our overview of Java, focusing initially on key object-oriented concepts and features supported by the language. These concepts and features include abstraction, inheritance, and polymorphism. Although in general, our goal is to focus on modern Java's functional programming concepts and features, understanding Java's object-oriented foundations is important since they're pervasive in practice. And nearly any non-trivial Java program will include elements of its object-oriented and functional programming features nowadays. Java was originally designed as just an object-oriented programming language. Therefore, it should be no surprise that it supports key synergistic object-oriented concepts and features. And as we'll see as we go through these examples and the discussions, these different concepts and features work well together. We'll showcase these concepts and features via an example that defines a simplified hierarchy of set classes that are implemented using set classes in the Java collection framework. You can find this example here in my modernJava repository in the EX0 project in the OO folder. Let's start our discussion with an overview of data and control abstraction. Data abstraction supports well-defined application programming interfaces, or APIs. The use of APIs helps to decouple interfaces from implementations, thereby enhancing reuse and modularity. In particular, the implementation details don't get tangled up with the client code, so it makes it easier to reuse and easier to change over time. Control abstraction, and data abstraction for that matter, also help to shield programmers from low-level implementation details that lurk beneath the surface. Examples of control abstractions include common Java control flow constructs, such as iteration with iterators or loops, conditionals with if-else statements, and as well as switching and branching. For example, we're going to take a look at our case study shortly about the simple abstract set class. This class defines a foundational API as well as some data to make it possible to add, search, and iterate over elements in a set without revealing any implementation details to the client. In particular, the methods are public, however, the field is protected and is thus not directly accessible to clients. They have to access it only through the public methods. The next concept we're going to talk about is inheritance. Inheritance enables systematic reuse of existing data fields, APIs, as well as implementations by enabling a subclass to extend the capabilities defined in a superclass. For example, the simple abstract set class is actually a superclass root of a whole hierarchy of subclasses, including simple hash set, simple tree set, and simple concurrent hash set, as we'll see when we walk through the case study later. By the way, this design implements a variant of the decorator pattern, which allows the transparent decoration of one class or object by others. In particular, simple tree set is a subclass that inherits a field as well as the methods from simple abstract set. You can see the field is the actual set reference that it stores in simple abstract set, and then the various methods are iterator, add, and contains. In turn, simple abstract set implements the iterator method defined in the iterable interface, which is also another example of inheritance. We're now going to talk about the third concept and feature supported by object-oriented Java, that of polymorphism, which is a Greek word that means many-shaped. In the context of Java and object-oriented programming, polymorphism involves dynamically dispatching a subclass method via a superclass reference based on runtime type information. And this is very beneficial because it enhances reuse and transparent extensibility when used in conjunction with inheritance, which we just talked about. Let's take a look at an example. This example, of course, also comes from our case study EX0 we'll look at later in more detail. In this particular example, there's a makeSetFactory method, which implements the factory method pattern from the design patterns book, Elements of Reusable Object-Oriented Software. And this factory method creates the given or designated concrete simple abstract set subclass. As you can see in the diagram at the left-hand part of the bottom screen, there's different subclasses of simple abstract set, simple hash set, simple tree set, and so on. and makeSet takes a string, then goes ahead and creates the appropriate concrete subclass of simple abstract set. makeSet returns a reference that's actually stored in a variable of type superclass simple abstract set. So we're getting back a reference to one of these concrete subclasses, but we're treating it as though it's a reference to the simple abstract set. And then when we call the various methods defined on the simple abstract set, such as add or iterator or contains, the add method, or whichever method is called, will be dynamically dispatched using the superclass reference, but based on the type of the concrete subclass. So for example, if treeSet is passed in as a string, then makeSet will create a simple treeSet, but we'll access it through the simple abstract set reference. Why this is beneficial is because this allows changing the actual implementation. We can swap from treeSet, as shown here, to hashSet, as shown here, without affecting the client code at all, since there are no lexical dependencies that are exposed in the actual client part of the code that's calling the methods that are these virtually dispatched methods using polymorphism. Now, if you have little or no knowledge of object-oriented Java, and what I just talked to you about was all Greek to you, to quote Shakespeare, then you may need some additional hands-on experience. And if that's the case, I recommend you consider taking our Java for Android MOOC, which is available on the Coursera platform, which covers classic Java object-oriented programming. So that's the end of our overview of key object-oriented concepts and features found in Java.